Hello, everyone, and welcome to the Open Systems Media webcast, Secure by Design, building CRA-compliant firmware and embedded software from the ground up, sponsored by wolfSSL, Panther, and Kaigen. This is the third session of our CRA virtual event, which is taking place all day today. So thank you all for joining us here on this event. Obviously, an important topic. I'm Ken Briota, Editor-in-Chief for Embedded Computing Design, and I will be your host for today. If you're not familiar with us, please visit embeddedcomputing.com, where you'll find our coverage of everything related to the design and execution of hardware and software for embedded systems. We're chock full of articles, white papers, blogs, videos, podcasts, and lots more. We're always adding new content and technology coverage, so check it out. In today's session, we're going to be looking at how engineers will need to consider secure boot, secure update mechanisms, and encryption as default with CRA, and how that affects the selection of processors, operating systems, and third-party libraries, since components that lack long-term support may become non-compliant by default over time. This session is the engineering deep dive. We're going to get down into the weeds and get our elbows dirty. How you can architect CRA-compliant embedded systems from day one. Our speakers today are Sameeh Jubran, software engineer at wolfSSL, Srinivas Shankar, co-founder and CEO of Panther, and Paul Bradley, VP at Kaigen. Before we get started, let me just go over a few housekeeping items for you. The entire presentation is likely to take about 45 minutes. That's going to leave us some time to answer your questions at the end, and we will get to as many as we can as time permits. You'll find on the right side of your console window an area where you can enter your questions in real time. As I said, we're going to address as many as we can at the end of the presentation, so get your questions in when you think about them, and that way we can get to them in the order in which they're received. If we don't get to your question before we run out of time, someone from wolfSSL, Panther, or Kaigen will get back to you, depending on your question, with an answer as soon as possible. If you have a technical difficulty or some question pertaining to the operations of the webinar itself, for instance, your slides aren't loading properly or advancing, or there's some trouble with the audio, please put that down into the question box as well, and one of our technicians will respond as soon as they can with a fix for you. On the left side of your screen, you're going to see our speakers' full bios. There's also a clickable tab there that says Handouts, and that's where you can download a copy of the slides that are being presented today and some other material that you might find interesting. The on-demand version of this webcast will be available about 24 hours after we sign off today, so if you missed something or you want to go back and review or even share it with a colleague or a friend, you can find it again through the same link that you used to sign in today. A reminder that all Open Systems Media and Embedded Computing Design webcasts are copyrighted and may not be recorded without prior permission. One last note, make sure you check out our weekly news show in case you missed it, in which we round out some of the biggest embedded news stories every Friday on YouTube, and the accompanying LinkedIn newsletter, which comes out on Mondays. If you're subscribed to both, you're never going to miss any of your embedded technology news. This week's episode is a live embedded editor report from when I was at Automate earlier this week. That's enough for me. You're here to hear from our speakers and get down into the engineering weeds. So allow me to virtually hand off the microphone. Paul, I believe you're up first, and the floor is yours.
Yeah, thank you, Ken. So good afternoon, everybody, or well, good morning, and thank you for joining. My name is Paul Bradley, and I lead sales in Europe at Kaigen. Today, we're going to talk about the EU Cyber Resilience Act, and specifically my part is about what it means in practical terms for embedded device makers, IoT product teams, and the wider connected device ecosystem. So the CRA is not just another compliance framework. It's a signal that cybersecurity is becoming a condition of market access. For anyone building connected products with digital elements, the question is no longer simply, does the product work? It's also, can we prove that it's been built securely, maintained securely, and can be patched securely throughout its life cycle, however long that is. That's especially relevant for IoT and embedded systems, where products are often deployed for many years, sometimes in hard-to-reach environments, and where connectivity, identity, and remote management become critical parts of the security model. So at Kaigen, we see eSIM not just as connectivity technology, but as a secure foundation for connected devices. The goal today is to connect the regulatory direction of travel with the practical design choices that teams can make now. So Kaigen's role in this conversation comes from our focus on securing connected devices at scale. We're an eSIM and iSIM enablement company built around IoT, embedded devices, and secure connectivity. Our roots are in ARM, so we approach connectivity from the device and silicon perspective, not only from the network side. That gives us a kind of practical view of what OEMs and embedded teams need: small footprints, low power consumption, long life cycles, secure provisioning, and solutions that can be deployed globally. Keegan supports OEMs, module vendors, connectivity providers, MVNOs, and mobile network operators. We provide GSMA certified eSIMs, remote SIM provisioning infrastructure, profile generation, SGP32 eSIM IoT remote manager or EIM capability, and tools that help customers move from prototype to production. A key part of our positioning is that Keegan is connectivity provider agnostic. We help device makers maintain flexibility, one secure eSIM foundation, multiple connectivity options, and the ability to manage profiles, credentials, and device identities over time. So for CRA readiness, that matters. Our SGP32 and EIM capabilities are designed around secure remote lifecycle management, patchability, and long-term operational control for deployed devices. So when we say secure by design, we mean building secure identity, provisioning, lifecycle management, and patchability into the product architecture from the beginning. It's easy to think of compliance as a burden. It introduces obligations, documentation, process, and sometimes cost, but that's only half the story. For companies building connected products, compliance can become a commercial advantage. Customers, procurement teams, regulators, and partners, they increasingly want evidence that a supplier can be trusted over the full product lifecycle. That includes how the product is designed, how vulnerabilities are handled, how updates are delivered, and how long the manufacturer is prepared to stand behind the product. The data here is useful because it shows that many organizations already see compliance as a growth enabler. Some see it as a primary growth enabler, some of them as a quality and trust signal. Only a minority see it purely as an obstacle to market. That reflects what we're seeing also in the market. Security requirements are moving earlier in buying decisions. They're appearing in tenders and requests for information, product evaluation, and customer due diligence with working with new vendors. Compliance is increasingly part of how trust is measured. So for embedded device makers, the opportunity is to avoid treating CRA readiness as a last-minute audit exercise. Companies that build secure patchability, vulnerability response, and lifecycle management into their products early will be better positioned when customers ask those difficult questions. So the scale of the problem explains why regulation is accelerating. Cybercrime is now managed and measured in trillions of dollars globally. Every connected product becomes part of the broader digital infrastructure, and every weak point in the chain can become an entry point. For IoT, that risk is amplified by scale. You've got large fleets, you've got long product life cycles, you've got unattended deployments, you've got devices operating in industrial, consumer, energy, automotive, logistics, and smart city environments. Embedded systems are now facing the same kind of security pressure that general purpose computing faced earlier, but with extra complexity. There's a huge diversity in operating systems, hardware, chipsets, connectivity stacks, and deployment models. Many devices are resource constrained, some have no user interface, and many sit in the field for a decade or more. So the EU Cyber Resilience Act is one of the most significant regulatory responses to this challenge. It applies to products with digital elements and places obligations not only on manufacturers, but on importers and distributors. That changes accountability across the supply chain. The timing matters as well. Vulnerability and incident reporting obligations begin this year in 2026, so manufacturers need reporting channels, triage processes, and evidence workflows in place ahead of full application. And then from next year, from December 2027, the broader product obligations apply, including the secure by design requirements, conformity expectations, secure update capability, and lifecycle maintenance. So for products being designed or launched now, the CRA is already a present design constraint. So the CRA creates an operational shift for product leadership. More than 90% of IoT products contain digital elements, so the scope is intentionally broad. It reaches into embedded computing, industrial devices, connected sensors, gateways, and long-life IoT products. And there are three messages that matter most. First, security updates become a product requirement, not a nice-to-have. Manufacturers need the infrastructure, the processes, and the technical capability to monitor, assess, and remediate vulnerabilities over time. Second, the documentation and evidence become part of the product. It's not enough just to say that a product is secure. Manufacturers need to show how risks have been assessed, how requirements have been met, and how vulnerabilities and patches are handled. And thirdly, the cost of non-compliance is significant, up to 15 million euros or 2.5% of the global annual turnover, whichever is higher. But the biggest commercial risk may be loss of market access, delayed launches, or customers choosing suppliers who can demonstrate stronger readiness. That's why the eSIM or EUICC should not be viewed as a connectivity component. In a CRA context, it becomes a security critical part of the connected device architecture. It can hold identity, credentials, profile management capabilities, and with IoT safe, hardware-backed cryptographic functions. For embedded teams, the lesson is clear. Secure identity, root of trust, remote reachability, patchability, vulnerability management, and evidence need to be architected in from day one. And the practical question is, where should teams start? So CRA readiness can feel broad, but it becomes more manageable when broken into concrete capabilities. Product teams should ask, can we identify what is deployed? Can we determine whether a vulnerability affects a given product or component? Can we reach the device or the secure element? Can we apply a patch? Can we prove that the update was applied? And can we maintain an auditable record? This is where Keegan's eSIM and EIM capabilities become relevant. eSIM is not only a way to download a connectivity profile. In an IoT context, it can support secure device identities, lifecycle management, remote profile operations, and a foundation for resilient connectivity. The resources here are designed to help teams move from the regulatory language to practical implementation. The blog linked provides more context on CRA readiness, and there's a demo video which shows you how security patching through the Keegan eSIM and EIM can support a scalable operational model. The key idea is that CRA compliance is not solved by one feature. It's solved through a repeatable life cycle, design securely, deploy securely, monitor continuously, remediate quickly, and keep evidence. With SGP32, the eSIM IoT Remote Manager, or EIM, becomes the central control point for IoT eSIM management. It allows remote management of EUICCs and profile operations for fleets of devices, including constrained devices that may not have a user interface or may not be easy to reach. Keegan operates a SaaS-SM certified environment. So this is a GSMA security accreditation scheme for subscription management environment with an EIM, and Keegan Pulse as the operational portal and orchestration layer for eSIM operation management. This is important because production readiness is not only about having a standards compliant component, it's about having the operational tooling, the security controls, workflows, APIs, observability, and support model to run at scale. For device makers, this reduces the amount of undifferentiated infrastructure they need to build. It also helps them focus on product and consumer experience while relying on a secure, tested, standards-based eSIM management foundation. Features such as recovery and rescue logic, in-factory profile provisioning, and lifecycle operations are particularly valuable for IoT. They help teams handle real-world complexity, manufacturing flows, global deployments, changing operator strategies, profile failures, and long device life cycles. The practical point is that CRA readiness will be much easier for teams that can already manage devices securely in the field. That includes knowing what's deployed, triggering updates or profile changes, recovering from failures, and maintaining operational evidence. There are two audiences to think about here: embedded developers and manufacturers. For embedded developers, the starting point is design. Build with certified eSIMs and interoperable components. Make sure the device can communicate with an EIM in a predictable and power-aware way. Polling matters because many IoT devices are battery-powered or only intermittently reachable because of network constraints. Developers also need to test the full life cycle before development and deployment. Prototype, pilot, production, update, rollback, reporting, and verification. CRA readiness is not just about applying a patch. It's about knowing whether the patch has been applied successfully, delivering it reliably, and proving the outcome. This is where eSIM can play a bigger role than connectivity alone. With IoT Safe, the eSIM can act as a hardware-backed trust anchor for secure storage of credentials and cryptographic operations. That can support device authentication, certificate-based mutual TLS, secure onboarding, credential rotation, and attestation-style flows. For manufacturers, the focus expands to governance, cybersecurity testing, SBOMs, declarations of conformity, CE marking strategy where applicable, vulnerability handling, and long-term support all need ownership. A critical concept is reachability analysis as well. When a vulnerability is disclosed, the first question is not simply, do we have a fix? It's which deployed products are affected, are they reachable, and what's the safest way to remediate them? Keegan's eSIM enablement suite is designed to support the operational challenges behind CRA readiness. At the device level, we provide a production-grade IPAD or LPA reference implementation. So these are the components used in the device to reach the remote systems, and a portable CSDK that can run across Linux, POSIX, and Orthos environments. That helps customers reuse integration work across different products, chipsets, and deployments. At the platform level, Keegan EIM and Pulse supports the GSMA eSIM remote lifecycle operations, including campaign-style operations for groups of devices. These are practical capabilities for managing large fleets, especially where devices are constrained, unattended, or deployed for many years. Security is also built into the architecture. IoT Safe support can enable secure identity, dynamic certificate management, and credential rotation. The eSIM can therefore become part of the device's security architecture, not only its connectivity architecture. That matters because secure boot, signed firmware updates, mutual authentication, and attestation-style flows all depend on trustworthy identity and trustworthy keys. IoT Safe does not replace the processor's secure boot chain, but it can provide a strong hardware-backed place to protect credentials and to support authentication and attestation flows. The broader point is that CRA readiness requires a connected operating model. Secure identity, secure provisioning, remote management, patching, reporting, and auditability. Keegan's role is to provide the eSIM foundation and operational tooling that make those capabilities scalable. So to close up, the Cyber Resilience Act is pushing the industry towards a more mature model for connected product security. The timing matters. Reporting obligations begin in 2026, and the broader product maintenance and security update obligations apply from December 2027. So this affects products being designed now. The companies that respond best will be those that treat security as part of product quality and market access, rather than as an afterthought. That means choosing architectures that support secure identity, root of trust, patchability, remote lifecycle management, vulnerability handling, reporting, and evidence. Keegan's view is that eSIM and iSIM will play a central role in that architecture. With SGB32, EIM, and IoT Safe, they can support secure remote management, hardware-backed credentials, certificate-based authentication, secure onboarding, and attestation-style use cases. As a next step, we're offering samples of our SGB32 eSIM together with trial or demo access to our EIM so teams can explore what this looks like in practice. Please do get in touch with us after the session. We'd be very happy to support evaluations, discuss your architecture, and help you get started. So thanks for joining, and I look forward to the discussion and hearing from the other speakers and then to receiving any questions you might have. Let me hand back to Ken.
All right, and I'm going to immediately hand right back off because I believe, Sri, you're coming up next.
Thank you, Ken. Yeah. Hello, everybody. Good morning, good afternoon, good evening, depending on where you are. Yeah, my name is Srinivas. I'm CEO of Pantheron, yeah, a cybersecurity innovator. Yeah, we build technologies that allow you to build products that comply with the regulations that are coming into play today. Yeah, whether it is the Cyber Resilience Act, there's quantum safe, acts that are coming out around the world as well. Pantheron allows you the ability to build products that comply with all these standards. I'm I'm going to quote Paul on this. The need is now. Yeah, security is no more a luxury. It is a necessity today. Yeah, products need to be more secure. Products need to be built in a way that ensures security. So what do we get? How can we build our products, our networks, our solutions in a cyber resilient manner, brick by brick? Those are the pieces that Panther provides. We will provide you hardware with, with root of trust, provide you encryption technologies, whether it's PQC or AES. Yeah, we provide you tools that allow you to build out this solution. We provide you also hardware platforms along with all the schematics and solutions. We call that Pepper, which is available for you to build your edge devices. So cyber resilience, CRA, has changed engineering forever. Security was a little more of an afterthought, yeah, in the development cycle. Yeah, over the year updates were optional. Yeah, they were also, done in a way that wasn't very secure. Yeah, nobody maintained software bill of materials. Nobody knew where that software code was coming from that was integrated into the products. Yeah, and nobody bothered to look at the sanctity of any third-party software that we would license and use. Many attacks happen, and the realization is there that we need much better control over the security of our products. Yeah, so CRA mandates that you need to secure by default the product configuration. You need to continuously assess vulnerability and manage that. Yeah, you need to have very, very secure, very reliable update mechanisms so you can update devices that are already deployed. You need to ensure the supply chain is very well tracked. Yeah, very, very traceable. Yeah, and the you need to provide security support throughout the product lifecycle. Now, this has become a must across hardware, firmware, software, network architecture. It's not in any one layer, but across the entire product. So, when you look at the architecture itself, yeah, you have hardware. You need to be able to verify the boot. Yeah, you have the runtime layers. Where you have the beyond the bootloader and so on, and then you have the application layer. These are all layers that need to have their own protection. There cannot be weaknesses. Any one layer causes a weakness, your entire product comes under threat. So, when you look at the platform itself, what do we offer in terms of protection? One, we offer you hardware platforms that you can take, you can customize. They're available from us. Sometimes free, sometimes at a very, very economical cost. So you can take these, modify them to suit your requirement. This is called the Pepper platform. Yeah, we provide you also encryption stacks. So whether you're looking at AES, you're looking at, so implementations of AES like TLS or IPsec. So you need also a customized key exchange free encryption approach. On AES or on PQC, we provide all of these stacks. We provide the entire network stack itself. So if you're building products with layer 2 or layer 3 functionality, TSN, MPLS, we provide stacks for all of this, which are secured. They don't use open source, so they're very trackable, traceable. Yeah. And then we provide you a high-level programming language, so you don't have to build, have the expertise to build out RTL code or something to program your silicon. You can have a high-level language that does that and generates the RTL code that can build out your network stack. So let's look at hardware root of trust. Why is this important? Without this, attackers gain access to your hardware. They can modify the bootloader. They can modify the firmware and compromise your entire product. This has happened many times around us. Yeah, and the hardware root of trust allows for the silicon, be it ARM or RISC-V or even FPGA, yeah, to secure itself, ensure that the boot sequence is cryptographically verified. It's mandated in the next year or so across the world to have PQC signed boot sequences. Yeah. You have firmware integrity to be verified. So as you boot, you ensure that the right kind of firmware is what boots up, not something that somebody else intercepted and programmed. There's also during runtime, you're also looking at ensuring protection of the hardware. So these are all immutable. These are all musts in the whole development process in terms of building your product. Yeah, you need to also have secure key storage as well as cryptographic acceleration, because none of these things are going to work by themselves. You need to have some acceleration for it so that you don't wait endlessly for the hardware to boot. Yeah, so the secure boot architecture, which we provide. Okay, as you power on, you'll have a root of trust. The bootloader is verified, the OS is verified, and then the application that loads and runs is also verified. So all of this comes to you as architecture uh, um, that that Pantheon can provide to build out your edge device, your IoT device, or your network. So, when you look at CRA, these are very important criteria. You have native secure boots, which we talked about in the previous slide. Yeah, you have TPM integration, you have ARM trust zone or equivalent secure enclaves where you can store keys. Yeah, and you need hardware cryptographic acceleration, because you are going to have to run things like AES or PQC to implement the secure encrypted flows as part of your product. Yeah. Another very important thing when you build your product is to have availability of parts. You need long-term availability of parts, because you don't want to be changing parts every few years. Yeah, so if you can get, parts for your product that have 10 years plus of life cycle, yeah, that makes a lot of sense. Yeah, you need to have a documented security patch policy. Your customers need to know about it. Yeah. When you do open source, you need to have verification for where you get that code from. Yeah. And then you need to do a continuous verification for vulnerability. Yeah. So all of this Pantheon provides you. We also provide you an FPGA-based hardware approach, which can allow you to build much more secure products with acceleration, AES acceleration in hardware. So you don't have long boot cycles, long encryption delays, or latencies in your communication. So all of this is built into our offerings. So why an FPGA? FPGA provides you significant advantages. It allows you better throughput and better performance without having the sequential operations that you would do with the CPU. Yeah, there's timing unpredictability as well when you do a complete software-based solution. And then there's a significant attack surface, because you can have runtime attacks as you run software DDR memory. Yeah. So also with the acceleration that FPGAs provide, you can have a lot of parallelization, even of encryption, as well as communication, as well as the control function. Key management is handled. Packet inspection can be handled as well. So these are all the benefits that you get with programmable silicon like an FPGA in combination with a processor like ARM or RISC-V. And we also provide a comprehensive OTA update framework. We call it the Pantheron Snow. Yeah, it's built ground up where you can build your firmware. You can sign off on it with PQC algorithms that we support. You can track all of the various places where you access all your code from. You can encrypt this and you can send it out over the air. You could use 5G connectivity to send out your firmware. You can use Ethernet. You can use various other modes of sending out firmware, all supported over our OTA framework called the Snow. And we have encryption technologies as well. Yeah, we of course interoperate with TLS and IPsec. Okay, but our encryption technologies allow you to have a maintenance-free AES where you're not always looking for certificates. We don't do a key exchange, so there is significantly less hardware you need to put on your network. Like HSMs and so on. Yeah, and we're able to do latency-free encrypt and decrypt without any handshaking. So in all these ways, we provide you also a encryption stack that allows you to encrypt your firmware, encrypt your communication between devices, and so on. And all of this is CRA-compliant technology. Yeah. Now, when you look at maintaining the software bill of materials, so the SBOM, you need to, if you're using open source, you need to make sure that you track the versions of your kernel, you track the versions of all your drivers, various toolboxes you use, middleware applications, libraries, including if you use TLS or OpenSSL, or you use our Stealth AES. You need to track all of this. You need to maintain this information. There are multiple formats in which you can maintain it. SPDX or Cyclone DX are typical formats that you could use. It needs to always track the vulnerabilities per component as well. This is very important. You need to also track security patches that you're putting out there for OTA updates. And this is the continuous process. You maintain the SBOM inventory. You continue to do risk assessments. You monitor for vulnerabilities, and then you fix those, patch them, deploy using over-the-air software. So this is a continuous process that CRA mandates. And it's important to have all the tools and all the solutions to be able to do this on an ongoing basis. Another offering that we have that helps you build out your solutions fast, particularly in the networking space, is we provide you a high-level language called P4. This allows you to program your requirements in. We provide you a compiler as part of the suite, so it can convert all of this high-level code into Verilog and VHDL code. So you can use that to program silicon. You can use that to program an FPGA. So this allows you significant ease with respect to building out your solution. At the same time, allowing you to build out, a solution that's not reliant just on fixed silicon. You can use an FPGA. And you can do a lot of additional solutions with the P4 language. You can do max spoofing and hard poisoning. You can do DDoS pattern detection, replay attack prevention, unauthorized device detection. So all of this can be IP that you build on top of P4 and deploy it in your products, further building out the strength of your product. Yeah. And in the process, you build a CRA-compliant network architecture as well. We provide you the tools to do that. Edge devices can be built with our offerings. You can encrypt the transport layer or the communication layer with our offerings, as well as build out secure networks with layer 2 and layer 3 IP that we provide. Yeah, and all of this comes without any open source components. So allows you to go forward with your design without any fears of compromise. Yeah, so open source is today quite a significant risk. Yeah, so it's important that you protect against open source, deployments. Keep track of where the source code is coming from. This is a critical part of what you must do. Yeah. And we also provide the Pepper Edge FPGA Edge platform, so you can go on pepper.pantherun.com. Yeah, or you can reach out to us after this webinar, and you can apply for a free release of your Pepper hardware. Yeah, wherein you get a completely designed edge hardware with multiple Ethernet and 4G interfaces. You can build your own product with this. We give you the schematics, Gerber, all the boot code, and so on. So come to us, talk to us about it, and you might win your own free Pepper board. And the idea behind CRA is not a policing approach. It is to enable greater security across platforms. Yeah, with core trust. Securing the runtime, resilient networks. Yeah, and we also you can look at the checklist here where you have a checklist for hardware, firmware, software, as well as networking. Yeah, and it's important to make security the design primitive. It needs to start on day one. Yeah, so we give you the platforms to be able to do this. Yeah, and I hope you will reach out to us to talk about your next design and use the tools and enablements that we provide to build that into your design. Yeah. Thank you so much, and handing over to Ken for the next part of this presentation.
All right, and I am going to once again do a quick handover to Sameeh, who's going to take over from here from wolfSSL.
Thank you, Ken. Hello, everybody. Thank you for attending. So without further ado, from black box to glass box, preparing to pass CRA before December 2027. I'm going to promise you that this presentation on CRA is going to be either the worst you've seen so far, the best, or anywhere in between. I basically guarantee that. And you're going to learn about CRA, and I have a little gift for you at the end, so you better stick. So we have less than 534 days left, counting today. And as early as September 11th, we already have some requirements specifically about vulnerability reporting. So we need you guys to start coming on Sundays. The fines of not complying with the CRA are up to 5 million euros, 15 million euros, and 2.5 of worldwide annual turnover, depends on which is larger. So we have a big risk and big responsibility on the line. Also, who's affected? So anyone, if it runs code or ships hardware in the EU marketplace, you probably are affected by the CRA. Personally, at wolfSSL, we are a manufacturer according to the CRA requirements, and we are planning to abide. So this is what I call a black box software today. If we take a look at what shapes the source code, if you think for it, like for yourself, there are many things that affect the source code. Governmental requirements, regulation, software specification, testing. Like there are many factors that can affect it. And the source code turns into a binary, as we know. So what we can say and tell about a given binary? I know some of you guys are good with reverse engineering the binary. You can tell what architecture it targets, maybe what compiler was it used to do it, but I can't tell much, and it's not easy to tell if I'm a customer. So that's what I call the black box software. There is no structured way currently for customers to validate the binary, what software is inside, answer what cryptography is enabled, what sources exactly used to produce this artifact, what hardware is it using, and is it exploitable, which CV is affected. So these questions aren't easily answered for a given binary. And in CRA, we're moving towards the clear box software. Basically, with the binary, we want to ship the bill of materials. Not only, CRA doesn't only require bill of materials, but that's one of the specifications. So we have the software bill of materials, which is can be provided in SPDX and Cyclone DX format. There's cryptography. There is cryptography assets, also which crypto was used. And like for AI applications, which models were used to train it. So here is a sample of what a CRA-compliant product release would look like. We basically have the binary, and we have various formats that we can provide either for the software bill of materials, hardware bill of materials, and whatever is required from us. So here's an example of a sample software bill of materials. We'll talk about it more in the upcoming slides. Basically, with the binary, we ship this kind of informative file. So why, who, and when about CRA? It's basically an EU-wide harmonization. It's for the sake of the customers and the companies themselves to keep track record and easy accessibility for the whole industry, and to keep also the customers safe. There's an emphasis about secure by design. Who is affected? Basically, if you ship code or you are a manufacturer of hardware and you place it in the EU market, you are affected, and you need to understand what is required. We talked already about the timeline. Tight dates on the line. September 11 is already coming. So what is required from us to pass CRA in simple words? So basically, we can take a look at three things. We want to be able to see what's inside each software that is delivered or hardware. We want to be able to stay secure over time. This can be accomplished using our crypto libraries such as wolfcrypt, or secure boot such as wolfboot. And also we want to be able to protect what moves, basically the data in transit. And in other words, we can say it like this: we want to look at the data at rest, at the data in transit, and firmware updates over the air. We also support that using wolfboot. We have also the security for various protocols for transfer, and we have solid cryptography at wolfSSL. So basically, you want to answer these questions. You want to know your software components. What packages do they use? What's the software bill of materials? You want to implement a secure boot. Basically, if the boot is the most critical and vulnerable part of a system, so it needs to be secure. And you need to take it into consideration. Also, we need to think about how the remote data is transitioned, like in space, and what security measures is used to make sure it is safe. So at wolfSSL, we provide you with the software bill of components and other bill of components that we are required to provide you with. For the secure boot, we have Wolf Boot, which is one of our flagships products. It supports over-the-air updates. It's specifically designed to embedded systems, powers embedded systems from medical devices to space. And we also have MQTT, and SSH, and TLS, and other data transfer protocols that can help you comply with the CRA. Here we can take a look at the wide variety of wolfSSL products, and it's still ongoing and getting bigger each year. We have one of the best and most heavily tested open source library for cryptography out there. We do like heavy testing, really heavy testing. And lately we even got lots of bug reports from Claude and Anthropic. We were even featured there with their AI scanning, which is might seem that there are some weaknesses, but everyone has weaknesses. And now after all of these scans, we are much, much better, and we're working over the hour just to keep it safe and AI proof and secure. So if we take a look at a typical application for a customer, it might look something like this. It has the application, there's the TCP/IP stack for connectivity, TLS and crypto, peripheral devices, runtime, real-time OS, and if there is a hardware manufacturer SDK. So a factory SBOM, the software bill of materials might look like this. We have this specific crypto version, this RTOS, this application version, this release. You want to assume that any component at any time might have a vulnerability in it. And it's a good assumption to make because security vulnerabilities can happen to anyone. This, for example, happened 2 years ago. It happened in the TCP/IP stack. So we need to always monitor the components, identify the vulnerability that may affect the system. So different components, different channel attacks. You have to attack down to the single CVE for each component and fix it for yourself. So we need to always monitor the components. So we made the TLS and crypto part really easy for you. We have really top-level support with wide variety of embedded devices, Linux, Windows, Mac, whatever you're using. We can support it even with very little footprints and thumbprints and very high performance. So how are we already preparing to pass CRA at wolfSSL? We already planning to provide the SBOM, the CBOM, cryptography bomb, the VEX, basically. How do we tell the European Union about vulnerabilities? There is also other stuff like the Omnibar, the BOM-SH. We'll talk about it in a minute. Hardware bomb, machine learning bomb, only relevant to whoever is using it. So we already have a pending PR. It's about to be merged. I believe it will be merged perhaps today or tomorrow, maybe next week. But the work is already there. We can provide the SBOM, and there is also support for BOM-SH, and we'll explain it easily now. So the software bill of materials basically tries to answer what software is inside. For example, if we have Ben and Jerry's, the ingredient list would say, basically we're providing the ingredient list. It contains flour, it contains sugar and milk. So that's how the process works. We give it all the header files, the source files, and metadata, and we have a Python script that generates either format, SPDX, and CycloneDX. On the other hand, BOM-SH, it's a nice paper written in 2024 that tries to create a way to create dependency graph of the artifact itself and provide like the actual artifacts that was used to build it. So BOM-SH basically tries to answer one main question: how this exact artifact was produced. So it's not just this car contains Michelin tires. It's more like these exact tires from this shipment installed by this robot on this date in this car. So not everyone is required to have BOM-SH, but we already support it. And if you need it, you can talk to us. So this is how it's implemented in our system. Some implementation details, you can find it here. So that's how you can use it. You can use it for embedded, RTOS, or Linux, or Auto Tools. At the moment, BOM-SH is only supported in Linux at the moment, but we might support other builds in the future if needed. So currently we're working mainly on the wolfSSL product, but we're planning to comply with all of our products, and there is already PRs in other products as well. We're working through them. So as I promised, I told you at the end I'm gonna give you a gift, and Christmas came early this year. So let me provide you with wolfSSL CRA kit. Basically, it's a kit that you can find CRA cheat sheet in GitHub. Also, you have an auditor packet, basically a sample of a fake company that tries to use wolfSSL and provide the software bill of materials. Also, for the AI, for the heavy AI users out there, we are not going to leave you alone. You have a skill.md to feed your AI and make the whole process moving into CRA and complying much, much easier. You can find the CRA kit in the wolfSSL examples PR. This is not illegal advice, and you can find the wolfSSL example in the CRA kit. It's in the PR 574 until merge. Hopefully it will be merged also this very soon. And I invite you guys to book a 30-minute CRA readiness session. Send us your availability and your questions at support@wolfSSL.com. Thank you, everyone. Back to you, Ken.
All right. Looks like we've got just a couple of minutes left here to do some Q&A, and we've gotten a bunch of questions in, as you might expect. This is all complex stuff. So I'll invite everybody to turn their cameras back on as we jump right in here. Oh boy, we're going to get complicated right away. I told you this was going to be our engineering one. Our first question here: the intersection of the EU Cyber Resilience Act and reciprocal open source licenses like GNU GPL v3 and LGPL v3 creates a direct legal and engineering conflict for hardware and embedded software manufacturers, says this one questioner. GNU-based utils in Linux become licensed from GPL v2 to GPL v3 or LGPL v3. How can engineers satisfy all of the above requirements simultaneously? And anyone, feel free to jump in on these. I know we're getting complicated down in the
Hi,
weeds.
since wolfSSL is already GPL v3, the question is relevant to us, but it's the first time I hear about this kind of requirement. I will take it with the team, and we are planning to comply 100% with the CRA, so we need to figure this out as soon as possible. I would be happy to check out with the team and give you an answer. Zednik.
All right. Anybody else have an answer right offhand?
I mean, I think GPL v3 is the driving factor today. Yeah. I mean, it's more about complying with that as you factor in cyber resilience. Yeah.
Mhm.
So I would look at it more from that angle, wherein you would take V3 as the primary. Yeah. But the issue is some level of code, I mean, comes under different GPL versions. So I mean, as much as possible, look at your components being one of the versions rather than mix of all versions.
Yeah, this is really complicated stuff, and I think we're all going to be figuring it out. So we appreciate all of your help. I think there's time for one more here, and so although we've got a bunch of questions pointing to some very specific things, this one's a little bit broader, so I think we'll end on this. One questioner says that in their experience, some hardware manufacturers don't register vulnerabilities in the CVE databases, but they do publish notifications on their own specific web pages. And then, of course, it becomes a little bit complicated to track vulnerabilities that have been discovered and things like that when they're not all in one centralized database, which hypothetically is what CRA is hoping to accomplish. Does the CRA make it obligatory for manufacturers to report all vulnerabilities that are known into CVE databases, or is it a different database, and why?
So my understanding on that is that each national, let's say, authority will have their own database, which consolidates the answers across the various member states, and then ENISA. So there will be a reporting platform made available, and then that will all get consolidated across the different member states without having to multiply it. Now, with regards to manufacturers publishing their own information, I guess that remains a possibility. Many manufacturers nowadays have a security center where they will publish any vulnerabilities that have been disclosed according to how it's mandated by ENISA and other practices. But then it will all be consolidated by reporting once.
Okay. That makes sense to me. Out of curiosity, we had this come up on an earlier session in today's virtual event. The disclosure requirements, does it explicitly call for those disclosures to be made after a patch or repair has been created, identified, etc.? Or do these disclosures have to be made even if it's not already patched? I know usually in the security world, we don't disclose vulnerabilities, even if they're known, until they've already been repaired, so that they're not being exploited. Does the legislation call for that delay in reporting? Do you know?
As far as I know, there's a notification period, and then during which you can investigate. And then between the notification period and the period in which you have some time to do a technical investigation and to develop a patch. But there's a notification deadline, which is, if I remember correctly, 24 hours. And then after that, you have to you have time to develop your patch. But at least the reporting has a specific obligation.
Gotcha. I think that runs us just about out of time, unfortunately. But remember, folks, if we didn't get to your question, and I know there's a bunch of you that we didn't get to them, one of the folks from wolfSSL, Panther or Keegan will get back to you as soon as they can with an answer, depending on who's most appropriate for your question. Remember, you will receive a link to the archive of this presentation, so you can view it again at a future date if you wish. I'd like to thank Paul, Sri, and Sameeh for the great presentation, and wolfSSL, Pantheron, and Keegan for sponsoring this event. The next session in the CRA virtual event is on what the CRA actually means for embedded engineers. The deadline is looming, and that session begins in about 15 minutes. So thank you all for attending. Thanks to all our speakers today, and we'll see you all again real soon. Thanks, everybody.